Some historical facts about cryptography. So cryptography is actually very related to warfare. Okay, the history you can trace to ancient Greek, Chinese, Indian, or Asian civilization. When there's a war, there will be something about cryptography. The rule becomes very important when the information is sent over the air. Like you have a telegram, have radio, and the information is sent over the air. When information is sent over the air, means that the enemy is able to intercept it. And hence, some form of protection is required. Cryptanalysis is the attacks on cryptography. Cryptography is actually means protection. Cryptanalysis means attacks. And to break the crypto, one way is to use a lot of computations to break crypto or cryptanalysis. In fact, cryptanalysis is the driving force, it's one of the important driving force to the invention of computers. This was around Second World War. Okay. For example, the Corazza computer and so on. So in World War II, okay, we already started to send information over the air. At that time, there's no computer yet. Okay. Sadly, computer reason that we have computer now is because due to World War II, then we want to need to do a lot of computation, in particular to break the crypto and then push the invention of computer. But anyway, during World War II, there's no computer. Information is sent over the air, and thus there's a need of encryptions. Okay. And there are machines built to encrypt things, okay, without using computer. Okay. And there are machines built to break encryptions. Okay. Two famous examples is the Enigma, is an encryption device used by the German, and the bomb that break Enigma. Okay. In the Atlantic theater, in the Europe, okay, the Enigma is the encryption used, and then because the breaking of it, okay, help allies to achieve their victory earlier. In the Pacific theater, it's a midway, okay, the midway battle, okay. There is a breaking of Japanese cipher that helps the Allies to win the war. Okay. What is Enigma? This is Enigma, okay, this is an encryption device, and the right-hand side is the device that break it, right? So in this Enigma over here, that's very interesting. There are some concept to, you have most of the modern concept of encryptions. To use it, you need to know the secret key. The secret key is a rotor. This rotor is detachable. You can take it out. So there are many different rotors. I don't remember how many. Let's say 20. So the secret key is to put the correct rotor in the right condition, right place. They also have initial value IV in the sense that the starting locations of the rotor form the IV in some sense. Okay. Then there's a plug box here, also correspond a secret key. You take cable to join them. For example, you take two cable to join from 1 to 3. So this 1, 3 is a secret key. To encrypt, you type on the keyboard here. This is a plain text. You press P, something will light out. Let's say D. So P will go to D. X, you press X, may go to A. Then you type P again, oh, it may not go to D anymore. Okay, it's not a simple substitution cipher. Okay, you can imagine that it is a substitution table cipher that change every time you type. Okay, so this is the Enigma. And this is the one to try to break it. How to break it? They get many, these are the rotor. These are rotor. Because the secret key is a rotor, right? This one. So you put it here, put many different combination of rotor, and then try to rotate it. Okay, rotate. This is in some sense a exhaustive search of all possible key. Okay. This during Second World War, okay, modern cipher. Modern cipher refer to those that is built for designed for use for the computer era. There are some field example, okay, that is not secure. A famous one is DES. It was very popular. It's a standard, okay. And that time, that was during Cold War. Okay, cryptography was considered as a weapon. Okay, it's as subjected to export control. Okay, and when it was designed, people feel that there could be some backdoor implemented it. This designed by the US. Okay. But later on, after many years of analysis, we now believe that probably no backdoor. It's not very strong encryption, but it doesn't have backdoor. But yet it have another backdoor in the sense that the key length is only 56 bit. At that time, it's almost near possible to exhaustively try 56 bit in reasonable amount of times. So it was designed so that the length, the bit length is short, it's sufficiently short that possibly the US government is able to break it using faster computer. Right. So in 1998, was broken in 56 hours. Okay, yep. RC4 is another one. There's a designed by Rives. Okay, and then there's some flaw in the design. Okay, so then when you use it in the wrong way, then you will leak a lot of informations. Okay, it was used in WEP. WEP right now, if we use our Wi-Fi, you at home you probably have a Wi-Fi router. Okay, how do you remotely connect to the router? You need a password. There's encryption involved also, right? And then very likely you are using at your home something called WPA2 personal. Okay. Before WPA2 is WEP. This WEP was widely used until and they use RC4 as an encryption scheme. But then later also found that there's a flaw. Okay, and we can able to derive the key very fast. So for that, the community industry switched to WPA2, okay, which is now using AES. Here are some interesting movie about encryptions. Okay, first one is Imitation Games. It's on the mathematician Alan Turing. Okay, you probably have heard of the award called Turing Award, right? In Nobel Prize, doesn't have the item field on mathematics and computer science. Computer science was treated as a form of mathematics, right? So Nobel Prize doesn't have mathematics and computer science. So for mathematics, they have their own award, few medalists, and in computer science is Turing Award, equivalent to Nobel Prize. And how is this related to crypto? Okay, Alan Turing is one of the chief architects of this bomb to break Enigma. Okay. Another movie is U571. Okay, what is this? Okay, U571 is a fictional event. There's no such thing. Okay, but they're actual event. Actual event. This is about capturing of a submarine. The U-boat is a submarine. Okay. At that time when there's attempt to capture a submarine. So if there's a submarine there, I mean, in the warfare, you saw a submarine, you just try to destroy it and sink it, right? But there is a incentive, very huge incentive to capture it in one pieces. So why do they want to capture a U-boat? Why you want to capture a U-boat? The main thing, they are going after a very small piece of device, which is the enigma. Right? They want to get the design of the algorithm. They do not know the algorithm. They know it's been encrypted and use a device called enigma to encrypt it, but the ally doesn't know the algorithm. So they need to get hold of the algorithm. So how do they get hold of the algorithm? Capture one. So go capture the whole U-boat intact and get the enigma. So in the actual events, in fact, there are quite many. 1, 2, 3, 4. 4 U-boat being captured alive, intact. Okay, with that, I end my session. Hope you learned something from it. Thank you.